So here we go, number 3. Number 3 says, what's the value of A? You've got this weird figure here. Looks something like this. And you got 127, 71, 102, and A. Folks, what kind of angles are these? Exterior angles. Exterior angles, our magic number is 360 degrees. What am I going to do with that 360? Some of you do like I do, and you take 360 minus 127, minus 71, minus 102. Some of you add 127 plus 71 plus 102. You get a sum, and then you take that sum away from what number? 360. It's the same difference. It's the same thing, okay? When you subtract those numbers off, you get 60, which is my value of A, okay? Does that make sense? I don't remember who asked. All right, 3 is done. Let's look at 11. Y'all will have to help me remember which ones. 11. Okay, what kind of figure is this? It says it's a rhombus. That means you got to know all of the properties of a rhombus. It says that JML, folks, that's that big angle over here on the left. JML is 70 degrees. What's the value of JKM? JKM. This is the value I'm looking for right here. Okay? Now, can you what? Can I divide 70 by 2? Yes. Why? What does this diagonal do? It bisects this angle, so that means that both of those little angles are equal to what? 35 degrees each. Well, how do you know that this angle right here is congruent to this one right here? Because what? Say it again. No. Say it again. Is that because it's a rhombus or because it's something else? It's because it's a parallelogram. A rhombus has all of the properties of a parallelogram. Okay? So that means if this angle M is 70, then angle K is 70, which means the diagonals bisect each angle, 35 and 35. Okay? Does it make sense now? That's the main thing. Does it make sense now? Okay? Was 17 the next one? 12. Part 35 is your answer. All right, look at 12. What kind of figure is this one? No, it is not. Read the problem. It's a rectangle. How many of you actually read the problem? Okay, it's a rectangle. It says, which statement is needed to prove EFGH is a rectangle? And it says EG is perpendicular to HF. Those are the diagonals. Or EG is congruent to HF. Chase is always my go-to man on this question because he answered this question yesterday before the test. I said, what must you ensure to have a rectangle? And he said, you got to make sure your diagonals are congruent. Well, folks, look at this. If this is a rectangle, it doesn't matter if it doesn't look like a rectangle. It's telling you that it is. What must you have true? The rectangles have to be congruent. You will see that again. I promise you will see it again. Therefore, HF must be congruent to EG. The diagonals have to be congruent. Please write that down on your paper. The diagonals must be congruent in order for you to have a rectangle. If they're not congruent, it's not a rectangle. Some other figure. And in a rectangle, the diagonals aren't always going to be perpendicular anyway. Think about it. The diagonals are always perpendicular in a rhombus. Yes, whoever said that. Look at that, too. Doesn't this look like our traditional rectangle? Okay, now look at those diagonals. Are they going to be perpendicular? These form 90-degree angles. No, I see two acute and two obtuse angles, don't y'all? So see, you got to be careful. Read the problems. Read the problems. Does that help on that one?
Yeah.
11, 12, 17, 18, 19. All right, so let's go. Is that whole back page?
Yeah.
All right, whole back page. Let's look at it. Folks, I'm going to tell you right now, your test is going to look more like 17 through 20 tomorrow. It's not going to be this little mamby-pamby crap. Okay? It's going to be elevated. The problems are not going to be simple little problems. J, K, L, M, and I want to know the value of angle K. Well, what kind of figure is that? No, don't tell me what it looks like. Tell me what it says it is. It says that it's a parallelogram. How do you know that? It has the symbol J, K, L, M. That means it's a parallelogram. All right, let's look at the information we're given. What kind of information are we given? What is the 8x plus 1 and the 16x? It's angles. What kind of angles? They're interior angles. What kind of interior angles? Consecutive. They're not opposite. They are consecutive angles or same side interior. What do you know about the consecutive angles in a parallelogram? So we got the measure of angle J plus the measure of angle M equals 180. I want somebody to finish this problem for me, please. Go ahead. All right, so we know the consecutive angles are equal to 180. We've got 8x plus 1 plus 16x minus 13 equals 180. We combine like terms. We added 12. We divided by 24. Boom, x is equal to 8. Where do you think x, 8, is going to be on the thing? It's going to be option A. Finished? Okay. Okay. It's going to be option A. And how many of us do you think, and I would be guilty of it too, y'all, how many of us do you think are going to choose A? I'm going to, until I slow myself down and say, hold up, let's just think about it. Okay? Thank you.
I always ask what this question.
Well, that's good. That's very good. We're going over the test. The one you just finished. Okay? Okay? Now,
The last question, I was kind of confused with that because there's like, I tried different ways and there's like two they could actually like.
and that's exactly right. Don't be confused. You got it right. If you chose either of those two, you got it right. Okay? Okay, yeah. How many of you had 65 or now you do understand how to get 65? Hands up. Fair enough. Let's look at the next one. 18. 18. Let's look at 18. 18. Oh, what kind of figure we got here? We got a kite, because kites are very important to geometry, aren't they? Not really. It's kind of crazy, in my opinion. What is that in the middle? Y? All right, it says in kite, that's important, UV, WX, the measure of angle XUV, this whole thing, is 84 degrees. It says WVX here, this one is 68 degrees. What is the measure of VWX? What's that measure? VWX, which is this one. I want to know that whole angle measure right there. Now, how are we going to go about finding it? you're saying, would this one down here be 68? Yes, you're right. Why is he correct on that? Look right here. I didn't put it in my picture because if you look at that bottom triangle, VWX, what kind of triangle is that? It's an isosceles triangle, folks, right there. So if that angle is 68 degrees, then this one down here at angle X is also 68. What else do you know about the diagonals in a kite? They're perpendicular. They're perpendicular. So folks, look, you got to draw on your knowledge of triangles. Two right triangles too, isn't it? How am I going to find that little angle right there? 180 minus 90 minus 68, which is what? I have the squeakiest shoes on ever. 22. See, don't listen to them. I'm going to take them off. I'm going to throw them at the door. Stop it. What? Check and make sure it's 22. Jody. It's 22. So if this is 22 degrees, what's this one right here? And then how can I find the whole thing? Add them together. 22 plus 22 is 44. Aha! Can't do that. Do you know it now? Okay. That's the thing. Folks, what do you have to do to not... Wait a minute. What do you have to do tonight or before you come in here tomorrow? Please study. Please. Okay? I don't just tell you that because I don't have anything better to do. I got a whole lot of other things that's a whole lot better to do than study. So do y'all. But we got to study. Have to, please. Look at 19. Oh. Look at this figure. We got D, E, H, G, F. I got 14 here, got 8 here. And I'm told that GE is equal to 5x plus 2. And I'm told that DF is 8x minus 7. Now, Daniel, don't answer this question. Folks, what kind of a figure is that? What kind of a trapezoid? It's an isosceles trapezoid. Please write that down. It's an isosceles trapezoid. Because, do you know the answer? Shh. Okay, isosceles trapezoid. Now, folks, look at the picture. Even if you did not know the properties, look at the picture. What can you tell me about GE and DF? They're congruent. So, if they're congruent, what am I going to do with GE and DF? Set them equal to each other. 5x plus 2 and 8x minus 7. And then it's just algebra. I'm going to subtract 5x, and then I'm going to add 7. And I get 9 is equal to 3x. What is x? 3. Now, look at your problem. It's a good thing 3 wasn't an option, isn't that right? Because we'd have chose it, wouldn't we? What's it say? GE. Stall for GE. 5 times 3 plus 2, which is 15 plus 2, which is 17. 19. 17. Okay? Are we there yet? 18 was H. Are we cool with that one?
Yeah.
Number 19? I got you. Let's look at 20. What kind of figure is 20? Says it's a trapezoid, doesn't it? We got This middle piece is 24 centimeters, and it says PQ, XY, SR. And it says in trapezoid PQRS, if YX is the midsegment, what could be the lengths of PQ and SR? Folks, if that's a midsegment, what's the formula? And I say that loosely, formula, okay? Top plus bottom, okay? Now, what?
I think like you said that it
Yeah. I don't have a top and a bottom. So how do I determine? I look at the options given. Folks, if 4 was PQ and 8 was SR, holy. If PQ is 4 and SR was 8, right? I'd have 8 and 4, which is 12. What's half of 12?
6.
Is the midsegment 6? No. So it can't be F. And then 9 and 15. If I add 9 and 15, that's 24. Half of 24 is what? Not this midsegment, showing. So look at the same thing. 17 plus 31 is 48. What's half of 48? 24. So H will work. How many of you stopped right there and said, done? Please don't talk while I'm talking. Yeah, that's all right that you did. Look on at J, though. 18 and 30. What's 18 plus 30? 48. What's half of 48? 24. So this works too. I honestly have no idea why there are 2 options up there. I look at that and I think, well, what of those 2, what do you think would be the best answer? Because of this midsegment.
No. J.
Why? Why do you say J? Because it divides by 2 evenly. See, that's the way I look at it too. I look at it as J is even numbers. Now, are both of them right? Absolutely. Both of them are correct. So I'm going to count both of them right. Folks, the back page, 17 through 20, that's what you're going to see tomorrow. It's not, like I said, it's not going to be that Candyland version of the test. You're going to see a real deal test. But did you study? All right. Are you going to study now? Thank you. Okay. G8 is the SOL. This is an old version, so our new SOL number may not be officially G8, but the SOLs didn't change. It says you have to investigate and identify the properties of quadrilaterals involving all of these things. You've got a quadrilateral is a 4-sided polygon. You might want to underline that. You might want to highlight it. It says the segment that joins any 2 non-consecutive vertices in a quadrilateral is a diagonal. You know where they are. They're in the interior of the figures. It says a special type of quadrilateral in which both pairs, circle that, both pairs of opposite sides are parallel is called a parallelogram. Okay? You just can circle it or highlight it or whatever you want to do to it, okay?
I mean, just 2 words, both pairs.
Yeah. Yeah. All right, now, it says theorems that concern parallelograms. You've got the theorem, and it has it in words, and it has it in a picture for you. It says that opposite sides of a parallelogram are congruent. You have the words on the left, the picture on the right. Opposite angles of a parallelogram are congruent. Words on the left, picture on the right. It says consecutive angles in a parallelogram are supplementary, meaning they equal what? 180 degrees. Then it says that the diagonals of the parallelogram bisect each other. That's not new information. We already know those properties, or you should know those properties. And then you've got these examples, okay? Here's what you need to do. Flip over to, you've got a couple of examples to look at for the rectangle, for the rhombus. It's got all those properties. For the trapezoid even, it's got a median. Look at that median problem on the 3rd page. Mid-segment, rather. Okay, it says that it's a median. It's this one right here. That's not a very pretty picture, but it'll do. You are told that the median, well, where's the median in a road? The middle. So what would we call this? Mid. What's the formula for mid-segment? Times the top plus the bottom, right? All right, so here we go, folks. Fill this stuff in. I don't care that it's right there. Cover it up with your hand, and let's do the work to the right of this problem, okay? What is my mid-segment in this picture? 15. Fill it in. And it's 1/2 of, what is my top base? 6x minus 3 plus, what's the bottom base? Write this down. That's right. Let's combine some like terms. 6x and 8x and -3 and plus 5. That's going to give me 15 equals 1/2 of. What's 6x plus 8x? 14x. What's -3 plus 5? Plus 2. Now, I showed you a shortcut, so we don't have to distribute this fraction. What's the shortcut? Multiply both sides by 2, which is totally fine. Bless you. Cancel out on the right side. What's 2 times 15? 30 equals 14x plus 2. Tell me how to solve that, please. Subtract 2, and then divide by 14. You're exactly right. That gives me 28 equals 14x. Brandon said divide by 14, and we got x is equal to 2, correct? Okay? Go back and read the problem. This is the point where you don't immediately... Yes, ma'am? At this point, this is where we go back and we read the question, because we don't want to immediately click on 2 and be done with it. Read the question. It says, given trapezoid RSTV with median MN, find the value of x. Did we find the value of x? Yeah, so we're done. We did exactly what we were supposed to do. Now, that is a ramped up mid-segment problem. Can you do that? Absolutely you can do that. It's algebra, okay? Look at the next one, the practice problem, okay? You've got a proof there. We're not going to look at the proof, but I do want you to look at number 7. Okay. It says, decide whether this quadrilateral is a parallelogram. Do you know that both pair of opposite sides? Flip back to the first page. At the very bottom. Okay, look. The part that says tests for parallelograms. It said both pairs of opposite sides are parallel. The second one said both pairs of opposite sides are what? Congruent. The third one says, what's the third one? The diagonals bisect each other. It's on the very first page. The very first page of the same packet we're working on. The fourth one says both pairs of opposite angles are what? Are congruent. And then the very last one, this is that little one that we forget about. It says a pair, one pair of opposite sides are both parallel and congruent. Look, you better circle that on that first page. I want you to circle that last one, because that's the one that's going to bite us in the hind end, okay? Look at those. Now, go back and look at the picture. These are the tests that determine whether we have a parallelogram or not. Okay? Now, look at what we have. Is that figure a parallelogram? Well, I've got two alternate interior angles that are congruent, don't I? Where are their parallel lines? Is it the top and the bottom or the left and the right? If this is the transversal, that means that the left and the right are the parallel sides. Turn your paper sideways and look at the Z, and you'll see it. So I've got this pair, this left side and this right side. The left side is parallel to the right side. Do you guys agree? What else do we know about the left and the right sides? They're both equal to 25 millimeters or meters or whatever it is. So we know that the left side is also congruent to the right side. Is that figure a parallelogram, yes or no? Yes. By which test? Our number 5 test. Down there. Does that make sense, folks? Yeah? Look at the next one. Same tests, different picture. Different picture. What do you know? What things, Jade? That you keep that finger under check there, girlie. Say it again. Which sides? The top and the bottom are what? They're parallel. Write this down. And what do you know about the right and the left? They're congruent. The left is congruent to the right. Hey, is that a parallelogram? Is it? No, it's not. I don't have a test on that other slide that says if the top and the bottom are parallel and the right and the left are congruent, then we have a parallel. No, 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 no. I have to have the same set of sides have to be both parallel and congruent. Do I not? Yeah, go back and look. If I would have had both pairs of opposite sides parallel or both pairs of opposite sides congruent, they have to have both of those. One pair has to be both parallel and congruent. So, what's your answer, yes or no? Not a parallelogram. Not a parallel, say. What kind of figure is this? From the instructions, it says find the values for x and y that make safe a parallelogram. How can I make that figure a parallelogram? What do I need to have true? Be more specific. I need to set my opposite sides congruent. So that means 3y is going to be equal to y plus 8. It does. That's the name of the figure. S-A-F-E. It's just that paper. What's this value? Subtract y. We get 2y is equal to 8, folks. Divide by 2. What's y? In order for this parallelogram to be, in order for this figure, S-A-F-E, to be a parallelogram, I need for y to be equal to what? 4. What about x? We're solving for x and for y. 3x plus 5 equals 6x minus 25. Let's solve this 4. What it's saying is, what values of x and y will make this figure a parallelogram? X has got to equal 10, and y is equal to 4. Pardon me? I don't understand what you're asking. But you got to know all these properties of these polygons, or you got to know this formula so you can figure things out. The interior angles, the sum of the interior angles of any polygon. Write this down, please. The sum of the interior angles of any polygon, does not matter how many sides it has, is n minus 2 times 180. Our magical exterior sum number, and it's of every single polygon. What is that number? 360 degrees. It does not matter if it has 3 sides. If you add all the exterior angles up, it's going to equal 360 degrees. If it has 100 sides and you add all those exterior angles up, it's going to equal 360 degrees. Okay? There's another important word there. What is it? Regular.
Means divide.
Regular, mathematically, we know we got to divide. What is a regular polygon? It is convex. What else? It's a convex polygon that what? It has all angles congruent and all sides congruent. And when we see the word regular, usually what I make you do is I underline it and then I put a division symbol above it, don't I? We do that every single time we work these problems. Look at the example at the very bottom. No. It says that Harry is making a sign in the shape of a regular pentagon. Bless you. What's the measure of each interior angle of the sign? What's the measure of each interior angle of a sign? Folks, what do I need to do? Why? Why am I? What number am I going to put in here? Why? It's a pentagon, 5 sides, which is 3 times 180, which is 540. Do you guys agree with that? Okay. Why? Because it's 5 sides. Folks, what's 540 divided by 5? 108. So what's that mean? That means that every one of these interior angles are equal to 108 degrees. Okay? That's something that's real life. That's real life. Flip, it is a big sign. Now, what is it, an interior or an exterior angle? She's making a clock, and they want to know the angle between the 2 pieces of wood. Well, is she going to be concerned about the interior or the exterior angles? The interior. Okay, so we're dealing with interior angles. How do I find the sum of the interior? Is he right, y'all? Yeah? What number am I going to put in place of n? Why? Because it's an octagon, 8 sides. 8 minus 2, which is 6 times 180. What is 6 times 180? Carson, 1080? Okay. What am I going to do with 1080? Why? And why are the angles congruent? Because it's a regular polygon. So divide 1080 by 8, and what do you get? 135 degrees. So on that clock, every interior angle is going to equal 135 degrees. Do you guys agree? All right. You do? Does it make sense? Promise. All right. Look at the next. The design for a quilt piece is made up of 6 congruent parallelograms. That means that all of these angles are going to be congruent to each other, doesn't it? Okay, so this one's congruent to this one, congruent to this one, congruent to this one, congruent to this one, congruent to that one. What did I just form? Oh, I formed a circle, didn't I? Okay, which is 360 degrees. Well, hold on. Why? Each of the 6 parallelograms are congruent. Take 360, folks, and divide it by 6, and we get 60 degrees. Do you guys agree with that? Check this out. Check this out. 60 here. Now, that means that all of these are 60. I don't really care about all the other ones. I care about this parallelogram right here. If that's a parallelogram, what kind of angle is this 60-degree angle with this one? Are they opposite or consecutive? Consecutive. What do you know about okay, so consecutive angles equal 180. We've written it probably 3 times already. So if this is 60, we're going to take 180, take away 60, which is 120 degrees. Which is the answer? C, 120 degrees. Folks, that's the type of parallelogram problem you're going to have on the SOL. That's it, right there. You've got to see and use circles when you can. You know that a circle is 360 degrees. You know that. You've known that forever. You've known it for a really long time, not forever. Right? Think, if they're congruent, then we're going to divide by 6. We found that that angle was 60 degrees. We know that in a parallelogram, consecutive angles are supplementary. So that angle is 120. Look at the next one. That's all right. That's all right. Look at number 2. It says QRST is a parallelogram. What are the coordinates of vertex S? And you can barely see it. I want you to look at it real carefully and fill it in when you need to. Looks like this. You have 0, 0 is Q. You got this point is T, and it is C, 0. You've got this one is S, and it's blank, blank. And we got this one is R, and this one is A, B. Now, folks, this promise, you'll see it again. Promise. We've got to figure out what this ordered pair is, right? Now, when we think about ordered pairs, we think about going sideways first, then up or down, do we not? Okay. How many units did we go from 0 to C? What did we add to 0 to get to C? I added C. So, we went 0 plus C equals C, and we put it right there. I want you to draw it just like I'm drawing it, okay? 0, this is strange. This is very strange. But we added 0 plus C units equals C. So, what do we know about the opposite sides in a parallelogram? It's the same distance. Oh, is it A plus 0? It's A plus C equals, can I literally combine those? No, I can't literally say A plus C is AC. Hold on, because I don't have it in front of me. A plus C, folks, is A plus C. Okay? Hold that thought up. Let me look at it in just a second. And then, how do we know how high this thing goes? It goes from 0 to what? It goes from 0 to B. So what am I going to add here? 0 plus who? 0 plus B is B. And we're going to put it here, or kind of, sort of. Now, I know that looks strange, and I need you to think about that and take time and think about it. Let's look at the options. A plus C. What is the difference? Oh. C minus A. No, it's not CB because we're here at A for this first one. And what do we have to add to get over here? I got to add C units, so it's A plus C. Okay? If this were 0, 0, you don't have to write this down. If this were 0, 0, which is at the origin, and this were 3, 0, okay? And let's say that this point R was 1, 3, okay? What would I add from 0 to 3 to get over there? 3. So what would I add to 1 to get over here? 3. 1 plus 3 is 4, okay? What do I add to 0 to get 3? 3. 0 plus 3 is 3. And if I were to give you grid paper where you could literally graph it out, you could see and count, okay? Now, 4. Did it give us that? Oh, it sure did. Sure did. LM is 5x plus 3. Thank you. It's an isosceles trapezoid, folks. You better know how to solve that. We will review before your test tomorrow. Number 4, or your retest. Number 4 says, given ABCD is a rhombus. What do we know about a rhombus? All sides are congruent, right? Rhombus. It says ABCD. Let's throw it in there. Says AB is 18, BD is 20, which is the diagonal. To the nearest tenth, what is the length of AC? You better do what with that? Better think about that. What happens with the diagonals of a rhombus? They do bisect each other. You're right. Oh, they're perpendicular. That's going to be important to you. Circle number 4 and come back to that one, okay? Look at number 5. I got it right here. Number 5. I got F, G, H, J. And I got this little angle down here is 28 degrees. It says that this is a rectangle. And what's the measure of angle 1? You ought to be able to figure that one out. I just want you to put a circle around 4 and kind of bypass that one for now. Okay? Go to the G9 practice worksheets. It says, what's the measure of angle X in the figure below, folks?